Hello friends, I am Sound Pepper and I welcome you all for this sixth lecture series of transportation problem. So today we are going to discuss about stepping stone method, which is one of the technique to get the optimal solution of transportation problem. So today we are going to discuss about initial solution obtained by LCM for the example number 1, which we have already discussed in our first lecture. So if you don't know how to get the initial solution, then go through that first lecture and you will get the idea about the all initial methods. So in this today's lecture, we are taking the same example and solve it by using a stepping stone. So we are improving the initial solution and obtaining the optimal solution by using this method. And the same example we have taken in my second lecture, which was been optimal solution we have obtained by using a modi method. So let's check how this works, stepping stone, and how you can correlate with this along with the modi method. So in stepping stone method, we have to prepare a loop for all unoccupied cells. That number of unoccupied cells depends on this matrix. So as we know, m is number of row, n is number of column. So if you consider m by n matrix, in that matrix if you remove the number of occupied cell, that is m plus n minus 1, these are the conditions for number of occupied cell. So if you subtract this, then you will get the number of unoccupied cells. Clear? So as we observe, the larger the matrix we have, the larger the number of unoccupied cells will be there. So as we have a larger matrix, in that case the number of occupied cells will be large, and we require to prepare a more number of loops for the unoccupied cell. So in that case, stepping stone method will be bit calculus and it will become lengthy. So in that case, MODA method is suggested. So let's have a look for this method. So here I have a initial solution by LCM. So here allocation has been already made by using a LCM method, as you can see. Okay, now we are going to check the optimality of this solution by stepping stone method. So for that, first we will write down all the unoccupied cells available here and we'll prepare a loop for all and finding the opportunity cost for each unoccupied cells, for which we have highest opportunity cost unoccupied for the unoccupied cells. For that cell we are going to stress a further alloc further allocation. So we'll modify the allocation accordingly. Let's start with writing down all unoccupied cells available with us. As we can see, AP, another unoccupied BP, then BQ, then CQ. These are the cell addresses you can observe. Then next one is CR. We have left one BS. Okay, so we have written all unoccupied cell here, as you can observe from this matrix. Okay. Now we are going to trace a loop for all these unoccupied cells. So let's start with this cell AP. How we can trace the loop? So as you can see, the occupied cells available surrounding this unoccupied cell is, if you go from this cell to this and take a turn from this cell, then we do not have any occupied cells. So further proceeding not possible. So we are skipping this cell, going further. Okay, stopping here. If we take the turn from here, coming here, then we can take next turn. The next turn we do not have any occupied cells available here. Okay, so we are also going to skip this cell, coming forward, stopping here, checking. If we take turn from here, we have occupied cell here. If we take further turn 90 degree, then we have occupied cell here, and we can another take turn and coming back. So here our loop is possible. Okay, so we proceeding with this path. Okay, so as we know, for tracing a loop, the rule is you can go either horizontally or vertically, and you can take only 90-degree turn. Okay, so for that we have taken this loop. I hope it is clear to all. Now we are assigning a sign plus minus alternatively at each turn. So we have started loop from here, starting from here, plus minus plus minus and plus. Clear? So for this cell we are writing down the loop value over here and calculate the opportunity cost. So we have 12 minus 13 plus 7 minus 6. So this is our loop. As you can see, the loop is calculated value are 12, which is plus minus this 13. Okay, then next one is plus 7 and then minus 6. So this is our loop, and we have end up with all this summation, and you can calculate. The answer is 12 minus 13, that will be minus 1, plus 7 equal to plus 6, minus 6, that will be equal to 0. Opportunity cost is whatever the summation we are obtaining, multiply with minus 1, that will be our opportunity cost. In this case we have 0, so it is 0. Next cell, for this BP, we have to again calculate the loop value similar to this AP cell. So let's have calculation for this BP cell. So for this cell, if we start a loop from here, then if we move downwards, then we have this possible turn. From this we can move over here, and from this if we go here, then we can have another turn here, and then we can again have turn over here, and our loop is complete. Okay, so again we are going to assign a sign plus minus alternatively, plus minus plus minus plus and minus. Okay, let's we have calculations for this cell. So writing down, starting from 7 minus 6 plus 7 minus 13 plus 12 minus 8. Okay, so let's calculate what is the summation we are getting. 7 minus 6, that is plus 1, plus 7, that is plus 8, minus 13, that will be minus 5, plus 12, that is plus 17, minus 8, that will be equal to, so that is equal to minus 1. So when we multiply this with minus 1, we have opportunity cost is positive 1. Similarly, for next unoccupied cell we have BQ. So for this cell BQ, we can start to stress a loop. So for this cell, if we go from unoccupied cell here, we have, and we can again turn here, and again we have here, and this loop is completed. So we have started from here, plus, minus, plus, and again minus. So we can calculate and take a summation here. 11 minus 8 plus 12 minus 10. So that will be equal to 5. Similarly, we will take another unoccupied cell, that is BS. So tracing the loop for BS. So again we can have occupied cells available nearby. Like this. So we have started from here, plus, minus, plus, and this one is minus. So again we can calculate 14 minus 13 plus 12 minus 8, and that will be equal to 5 again. And when we multiply with minus 1, we have opportunity cost minus 5. Similarly here we have minus 5. For this cell CQ, again we have calculate. So take the loop. If we start coming here, take a turn, again we take turn from here. Okay, so plus, minus, plus, minus. So as we can calculate again, 16 minus 7 plus 13 minus 10, and that will be equal to 12. Okay, so opportunity cost is minus 12. Similarly, we can calculate for next unoccupied cell, that is CR. So for this CR cell, we can start from here, going here, and then we have this and coming back. So at each turn, again we are assigning plus, minus, plus, and minus. So as we can calculate for this cell, 11 minus 7 plus 13 minus 12, and that will be equal to 5. So we have opportunity cost is minus 5. Now we are observing the opportunity cost, which one having a maximum positive value. So as you can see, this cell is obtained with highest opportunity cost. So modification required to be done in this cell. So we are changing the allocation for this unoccupied cell. Okay, so let's see how we can modify this. So the loop we have traced for this unoccupied cell was starting from this 7, then 6 plus 7 minus 13, then plus 12 minus 18, and coming back. Okay, so this was the sign. We have assigned plus minus at each corner. Okay, Now out of all this plus minus sign, we are going to check the negative corner and their allocation value, as usually we have done in modi method. So at negative corner you observe the allocation value. Here it is 180, here it is 300, here it is 300. So out of all this negative corner, this one is minimum. So we are going to subtract this 180 at each negative corner and going to add this 180 quantity at each positive corner. So starting from this positive corner, we can allocate here 180. This positive corner will be added with 180. So modified allocation will be 230. Okay. And this is again added with 180. So modified allocation will be 200. Now all the negative corner we are going to subtract, so this will become unoccupied 0, and this 300 minus 180, that will bring you 220. Okay. This one is also become 220. Okay, now all this modified value along with allocation, we are going to rewrite this table, and again we are going to make a loop for all unoccupied cell, and again we will calculate the opportunity cost and check if we have any opportunity for further improvement or not. So this is first iteration we have completed, and we are going to move for second iteration. If we found again opportunity cost positive for any unoccupied cell, then we will go for third iteration. So now as you can see in this revised table, we have modified the allocation and we have new unoccupied cells available. So for this all unoccupied cell, again we are writing the all unoccupied cells and tracing the loop for the same. Okay, so first AP, then next unoccupied cell we have BQ, then BS, next is CA, CB, sorry, CP, CQ, and CR. So starting from this cell AP, what is the loop we can trace? Let's see. If we start from here, then we cannot take turn from here, skipping this, coming here. Yes, we can take turn here, and from here again here, and this is our loop completed. So assigning a plus minus alternatively at each corner and calculate the loop summation. Twelve minus 12 plus 8 minus 7, and that will be equal to 1, and opportunity cost will be minus 1. Next cell, similarly we can calculate for this BQ cell. So loop value, as you can see, from if we consider the loop from here, then here coming back. Okay, so plus minus plus and minus. So we can have loop value here is 11 minus 10 plus 12 minus 8. So that will be equal to 5, and opportunity cost we can have is minus 5. Okay, similarly we can calculate the loop value for BS. So let's calculate for this BS cell. If we proceed from here, then what will be the our next cell? If we go here, then we can take turn here and again here, and loop is finished. So plus, minus, plus, and minus. So we can calculate the loop value 14 minus 13 plus 12 minus 8, and that will be equal to 5. So we have opportunity cost minus 5. Okay. So next unoccupied cell we have CP, and for that we can trace the loop as from starting from here, moving here, next here, then we can move here, 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 and done. Plus, minus, plus, minus, plus, sorry, plus, and this one is minus. So calculate the value for this unoccupied cell. 6 minus 7 plus 13 minus 12 plus 8 minus 7. So the summation we obtain here is 1, and their opportunity cost will be minus 1. Similarly, for next unoccupied cell CQ, we can calculate if we moving from here, then here, here, and loop is over. So plus, minus, plus, and minus. So the loop value we can have is 16 minus 7 plus 13 minus 10, and that summation will bring you 12. So opportunity cost we have is minus 12. Similarly, for next unoccupied cell CR, as we can calculate, so loop we have starting from here, going here, here, again we can have turn. So plus, minus, plus, minus. So putting in calculation, 11 minus 7 plus 13 minus 12. So that will be equal to 6, and opportunity cost we have is minus 6. So as you can observe, we have all the opportunity cost over here are negative, and hence no further iteration is possible. There is no further modification can be done, and hence this is our final optimal solution, which we have obtained by using a stepping stone method. And here you can calculate the total cost as per the allocation made, and you can observe and compare this cost along with the solution we have already obtained for this example by using a Modi method. So you can also check out that my lecture which was obtained by using Modi method, the same example. Link for the same is given in description. Okay, thank you.